One of the most fascinating stories in aviation history is the creation of the so-called Volksjäger. In German, that translates to the people's fighter. Consider this. This combat aircraft was conceived, fully designed, and actually built in just 90 days. The whole idea for the aircraft came from the head of the German fighter staff, Otto Sauer. He was a loyal protege of armaments minister Albert Speer. Their concept was purely pragmatic. Create a fighter that was as simple and cheap as possible. It had to be perfectly suited for mass production. It needed to be constructed from non-strategic, readily available materials. And most importantly, assembled by unskilled labor. On September 8, 1944, the technical department laid out the main requirements for this ambitious project. The specification was immediately sent out to Germany's leading aviation giants. These included Arado, Blohm und Voss, Fuselage, Focke-Wulf, Heinkel, Messerschmitt, and Junkers. The requirements were strict. The People's Fighter had to be powered by a single BMW 003 turbojet engine. Its weight could not exceed 2,000 kilograms, roughly 4,400 pounds. The planned armament packed a punch, 1 or 2 30mm cannons. As for flight performance, the aircraft had to reach 750 kilometers per hour, around 465 miles per hour. It had to have an endurance of about 30 minutes and take off in a distance of just 500 meters, about 1,600 feet. The timeline was absolutely insane. Series production was supposed to begin by January 1st, 1945, and the companies had to submit their preliminary designs by September 20th, 1944. However, not everyone was on board. Legendary fighter ace Adolf Galland strongly opposed the project. He firmly demanded that all the remaining resources of the German aviation industry be poured into producing the already proven Me-262 jet fighter. His position was backed by two of Germany's greatest aircraft designers, Wilhelm Messerschmitt and Kurt Tank. They argued that the technical requirements and the tight deadlines were completely unrealistic. But the leadership didn't just ignore the criticism from these experts. They took it a step further. They actually ordered the deadline for the preliminary designs to be moved up by another 6 days, to September 14th. By September 15th, the Reich Air Ministry had already called a special conference to review the initial proposals. The competition didn't go according to plan from the very beginning. Messerschmitt refused to submit a design at all. They simply walked away from the competition. The engineers from Focke-Wulf submitted a design that was frankly impossible to build. The concept from Arado was rejected right out of the gate, and Heinkel's initial idea was deemed way too complicated to pull off. With the rest of the field falling short, the design from Blohm und Voss was chosen as the winner. Heinkel was represented at the meeting by one of its directors, a man named Franke. He was told straight to his face that their design was rejected for 5 specific reasons. First, the aircraft's endurance was only 20 minutes instead of 30. Second, the engine placement was highly impractical for maintenance. Third, the aircraft failed to meet the short takeoff requirements. Fourth, the fuselage was simply too long to be transported on standard rail cars. And finally, their armament consisted of only 20mm cannons. But Director Franke was not about to give up that easily. He pushed back hard. He argued that the commission had calculated the weight and flight performance for the different competitors using a completely different method than the one Heinkel was using. His persistence paid off. The very next day, all the competing projects were recalculated using Heinkel's formulas. On September 19th, they held another conference where the commission reviewed all the proposals again. New designs from Fuselage, Focke-Wulf, Junkers, and Siebel joined the mix. But there were no surprises. The Blohm und Voss design was declared the winner once again, beating out the competition in almost every metric. This meeting descended into total chaos and ended in a massive shouting match. The director of the main aircraft committee, Karl Freytag, who used to manage Heinkel, got into a bitter argument with military engineer Schwartz, who was lobbying for Blohm und Voss. Thanks to all this fighting, they never actually reached a final decision. Even though the engineers could not get on the same page, on September 23rd, a meeting took place at Göring's headquarters in East Prussia. During this meeting, government officials approved the concept in principle, clearing the way for mass production of the People's Fighter. Meanwhile, the head of the engineering department, Lucht, decided to personally inspect the mock-up of the Heinkel aircraft at their plant in Schwechat. As it turned out, chief designer Karl Schwerzler and the lead project engineer had been working on a similar idea since the beginning of summer. They had been planning to build a compact and incredibly simple jet fighter. They named it the Spatz, meaning sparrow in German. To see what this concept could actually do in the air, the engineers decided to flight test the BMW 003 turbojet engine they were planning to put in the Sparrow. To pull this off, they took an HE-2-19 heavy fighter prototype and removed the lower fuselage skin. Then they mounted the jet engine on a short pylon right underneath the fuselage. These highly unusual flight tests had successfully kicked off back in July 1944. Engineers Günther and Karl Schwerzler worked around the clock. They had to adapt their Spatz design to the strict demands of the Volksjäger program, the true people's fighter. Most of the specialists working on this ambitious project literally lived at the facility. They would not even leave their drafting tables at night, often falling asleep right at their boards out of pure exhaustion. And even though the official winner of the competition had not been announced yet, politics quickly overrode technical merit. Top official Karl Otto Sauer had already firmly made up his mind. The Heinkel design was going to be the fighter they needed. Hermann Göring, who was fully on board with the concept, threw his unwavering support behind the project. As a result, by September 24th, they were already manufacturing the first parts of the aircraft. It was a truly wild situation. The engineers were still drawing up blueprints while the production crew was simultaneously assembling the actual aircraft on the factory floor. The German Air Ministry held another conference on September 30th. By this point, the Heinkel project had already been publicly declared the winner. But after some fierce objections from engineer Karl Schwarz and other committee members, the meeting quickly turned into a heated and emotional shouting match. To settle the matter once and for all, the committee brought in respected professors from the Aerodynamic Research Institute. They offered their professional opinion that the direct competitor, the Blohm and Voss aircraft, would likely suffer from serious aerodynamic issues with its air intake. That verdict put an immediate end to the debate. The final decision was made. They were going to rush the Heinkel fighter into mass production at a staggering pace of 1,000 aircraft per month. At first, this fighter was given the working designation HE-500. But in October, to throw off enemy intelligence, the technical department changed its designation to HE-162. Interestingly enough, that number had previously belonged to a Messerschmitt fast bomber design. It was around this time that the new fighter received its famous nickname, Salamander, even though that name was originally meant for the overarching secret production program itself. The complete set of blueprints for the HE-162 was finished on October 29th, actually a day ahead of the incredibly demanding schedule. By that point, the first experimental prototype was already on the shop floor, nearly ready for testing. This was completely unprecedented in aviation history. Drawing up the blueprints, assembling the physical prototype, and tooling up the factories for mass production were all happening simultaneously. To handle mass production, officials planned to establish 3 massive assembly lines right from the start. These main lines were designed to be fed by a steady flow of finished components from a massive network of subcontractors scattered all over the country. While wooden structural elements were assigned to specialized woodworking groups, the metal fuselages were slated for assembly at numerous Heinkel and Junkers facilities across Germany. Production of the BMW 003 jet engines was moved deep underground into the salt mines near Erseberg. Other salt mine tunnels were urgently repurposed to provide a completely bomb-proof location for fuselage manufacturing. All the final design work and the construction of the pre-production batch of aircraft were consolidated in the town of Schwechat. It linked up with a massive underground complex located inside a gypsum mine beneath Vienna. The plans were incredibly ambitious. They aimed to hit a 2,000 aircraft monthly target by May 1945. Looking at the design itself, the HE-162 fuselage featured a monocoque structure constructed from a lightweight alloy, paired with a wooden nose cone. The single piece wing was also made mostly of wood, skinned in plywood with only metal wingtips. Interestingly, the entire wing was attached to the fuselage with just 4 main bolts. This was a design choice made specifically to simplify and speed up production as much as possible. The tail assembly and flight controls were constructed from light alloy, but the twin vertical stabilizers were made of wood. The landing gear had a fairly narrow track. It retracted completely into the fuselage, maintaining an exceptionally clean aerodynamic profile. The heart of this aircraft, the BMW-003 turbojet engine, was mounted in a highly unusual location. It sat externally on top of the fuselage, directly behind the cockpit. It was secured with several heavy bolts to let mechanics quickly inspect and service the power plant. The center of the cowling featured two fold-out access panels. Refueling the aircraft was incredibly straightforward, utilizing a single-point refueling system to feed the main bladder tank and the supplemental wing tanks. The cockpit featured a clear bubble canopy that slid aft, offering excellent all-around visibility. Inside, the pilot sat on a basic ejection seat powered by an explosive cartridge. The avionics were bare bones, a basic navigation receiver with a designed operational lifespan of just 5 to 10 hours. This was because the aircraft simply was not expected to survive any longer than that in actual combat. According to the original requirements, the aircraft was supposed to be armed with two heavy 30mm Mk-108 cannons. During testing, however, the heavy recoil proved too destructive for the lightweight airframe, and ammo capacity was severely limited. As a result, engineers fell back on the alternative armament, using two proven 20mm MG-151 cannons. The experimental HE-162 made its first flight on December 6, 1944. During the short test flight, the prototype reached 835 kilometers per hour, about 519 miles per hour. However, the flight had to be cut short when a gear door tore off in midair. Despite some directional instability, the pilot reported that overall the aircraft handled reasonably well. Just 4 days later, however, tragedy struck during a demonstration flight for Luftwaffe brass. The pilot made an unplanned high-speed pass over the runway. Suddenly, the leading edge of the right wing disintegrated in midair. The airplane instantly snapped into a violent, uncontrollable roll, slamming into the ground and killing the pilot. An investigation revealed the cause of the crash was poorly secured structural components. To clear up any doubts about the project after the horrific crash, Director Franke personally took the next HE-162 prototype up for a test flight, successfully demonstrating its full flight envelope. Meanwhile, engineers scrambled to modify the next few prototypes based on flight data. To improve directional stability, they dropped the wingtips downward, creating a distinct anhedral. As full-scale production of the HE-162A1 model began, a team of experienced test pilots was assigned to accelerate the flight test program. The aircraft assembled at the Hinterbrühl facility mostly served as flying test beds. Subsequent airframes were heavily utilized to test everything from simplified landing gear systems and thicker wings to extended fuselages for different armament setups. Some airframes were kept on the ground for static structural testing, while a few were even converted into two-seat training gliders designated as the HE-162S by removing the turbojet engine. Engineers also experimented with radical weapon pods like clusters of R-4M unguided rockets, though none of these wild configurations ever saw actual flight testing. The only version of the famous Volksjäger to roll off the assembly line in any significant numbers was the HE-162A2. Externally, it looked almost identical to the first experimental prototypes, though with slightly larger wings and stabilizers. The standard BMW engine was eventually swapped out mid-production for advanced versions that offered a temporary high-consumption thrust boost for combat maneuvers. Engineers also seriously looked into the possibility of mounting one or even two Argus pulsejet engines on the basic airframe. Despite huge skepticism from Heinkel designers, the disastrous frontline situation forced the military leadership to grasp at straws. Viewed practically as a disposable, guided anti-aircraft missile with a live pilot, this pulse jet variant was intended to alleviate the shortage of proper turbojets. However, facing severe issues with extreme vibration and massive fuel consumption, the project never made it past the drawing board. The design team also explored more futuristic evolutionary steps. The HE-162C project featured a swept wing and a distinctive V-tail, while the even more radical HE-162D was to feature a forward swept wing. Both variants were developed exclusively as short-range interceptors, designed to be armed with upward-firing Schräge music cannons to attack bombers from below. Ultimately, neither of these innovative variants were completed before the war's end, though Allied troops later discovered fascinating interchangeable wing components for them. Another fascinating variant, the HE-162E model, actually reached the flyable prototype stage. It featured a unique mixed power plant, a standard turbojet working in tandem with a powerful liquid fuel rocket motor for high-speed intercept climbs. Though incredibly fast, the design suffered from severely leaking rocket fuel tanks. Flight testing and pilot training proved to be a massive hurdle. Early on, the German High Command had a flawed plan to put completely inexperienced kids straight into the cockpits of these complex jets. Over time, harsh reality shattered this optimism. The jet-powered HE-162 was a highly complex and temperamental aircraft, difficult to handle even for seasoned aces. Command eventually decided to equip an already experienced fighter wing, commanded by Lieutenant Colonel Herbert Ehlefeld, with the new jets. Because of a severe shortage of airframes and constant delays, both training and combat operations were seriously crippled. By April 11, 1945, instead of the 120 aircraft they were supposed to have, the unit only had 16 in inventory, with just 10 mission-capable. The numbers were grim. From mid-March until the surrender, the wing suffered 9 pilots killed and 5 more severely injured entirely in training and non-combat accidents. Among the dead was experienced ace Oberleutnant Paul Heinrich Dana, who died when his complex emergency canopy jettison system malfunctioned during a crash. There are only a few recorded historical accounts of the new Heinkel jets engaging in air-to-air combat. On April 19th, Feldwebel Günther Kirchner radioed that he had successfully downed a British aircraft. Unfortunately, Kirchner was bounced by an American P-47 Thunderbolt minutes later and killed. On May 4th, Lieutenant Rudolf Schmidt shot down a British fighter at low altitude. However, German anti-aircraft gunners immediately claimed the very same kill, and in the chaos of the war's final days, Schmidt's victory remained officially unconfirmed. The combat career of the People's Fighter officially came to an end on May 8, 1945, when British tanks rolled onto the German airfield at Lech. 31 HE-162 fighters were neatly lined up, completely useless with bone-dry fuel tanks. As war trophies, the Allies divided up the remaining fleet. The Soviets managed to secure 2 airframes from the city of Rostock. This pair of fighters arrived in the Soviet Union in the second half of 1945, along with a massive amount of technical documentation. The Soviets always valued cheap, simple hardware that could be quickly mass-produced, making the jet's extensive use of wood highly intriguing. At one point, they seriously considered putting the Heinkel into mass production. However, as it later turned out, those high hopes were wildly premature. Right after Soviet specialists conducted detailed studies and flight tests, it became painfully obvious that the HE-162 did not meet the basic requirements of a reliable combat aircraft. Captured documents revealed that Heinkel engineers had deliberately sacrificed flight performance to rush the aircraft into mass production. The hasty design tweaks, like drooping the wingtips and adding stall strips, had severely degraded the fighter's overall aerodynamics. Because the difficult and frankly dangerous handling characteristics were well documented, Soviet test pilots approached the aircraft with extreme caution. A special commission laid down strict flight envelope restrictions, forbidding speeds above Mach 0.75 and capping maneuvers at a mere 2.5 Gs. Test pilot Georgy Nikolaevich Shianov was the first to take this captured fighter into Soviet skies on May 8, 1946. The test flights confirmed everyone's worst fears. The HE-162 was mushy and unresponsive in the air, the controls were heavy, and it constantly fought to hold a straight line. Furthermore, its takeoff roll was abnormally long, requiring over 1,300 meters, more than 4,000 feet, just to get off the ground. With problems piling up, the Soviet leadership immediately grounded the fleet. One airframe was sent to a research institute for wind tunnel testing, while the other was stripped down to the last rivet to reverse engineer its design. The biggest standout discovery for Soviet designers was the pilot's ejection seat, powered by a specialized explosive cartridge. Engineers also praised the modular manufacturing concept and the brilliant simplicity of the spring-tension landing gear system. Of course, they also uncovered comical design flaws. For instance, the transparent cockpit canopy hinged rearward in a way that, if left open, completely blocked the intake, making it impossible to safely start the engine. Generally speaking, from an engineering standpoint, the HE-162 earned pretty high marks, and Soviet engineers borrowed heavily from its technology when developing their own early jets. However, no one was planning to make a direct copy. Even before Soviet test pilots delivered their final verdict, the Soviet Union was already successfully flying its own jet fighters developed by Mikoyan, Lavochkin, and Yakovlev. The need to directly copy the rushed German fighter simply vanished.